Welcome to part 4 of my model railroad build video series. This video I'm going to install the Tortoise switch machines, wire them up, power the frogs, and we're going to start working on wiring up the LED control panel on the front of the layout where the track diagram is inscribed. So parts 1 of my video series, we did the track, bench or the cork, the track, did some of the soldering for the feeder wires. Part 2, we did a real in-depth of the wiring with the bus lines and getting all of that hooked up. Part 3, we ran all the modules, the SE8C, the LNWI, got the LocoNet wires connected, got the command station hooked up, and successfully tested out the track. So before we start running locomotives, we're going to get the Tortoise switch machines wired up, get the frogs wired up, and then start working on the wiring for the LED panel on the front. So let's go ahead and get started with the Tortoise. So before we go ahead and open up the case and get started here, I did the first part of the Tortoise setup back in, I believe it was the second series video version 2. So you need to drill about a 1/4 inch hole straight down so you have access to get a piece of piano wire up and put it through the throw bar. And also we needed to make sure that we have a wire coming off of the frog so we can power it with the Tortoise switch machines. And then on the underside, we actually already marked the location for where the tortoises are going to be. So if you are doing this for the first time, or if you're just watching this part of the video, go back and take a look at the caption on the screen here, and it tells you exactly which video and at what time frame in the video you can find where we did the initial installation of drilling the holes and getting the switch machines marked on the other side of the layout. So it is imperative to plan ahead. Part of the reason why I planned ahead and marked where the switch machines are going to be is because when I wired this up, I intentionally bypassed where the switch machines were going to be mounted. Now, there is a caveat to that. 2 of these switch machines, this one right here and this one right here, actually have wires, feeder wires running through where we're actually going to mount them. So I've got just a small piece of balsa wood board that I'm going to cut and actually just create a couple shims to basically protect where these wires are. So I'll get to that here in just a second. The other thing you want to do, again, once we got the holes drilled and marked, you just want to make sure that the Tortoise clears everything, that you have good access to the holes we drilled to get up to the throw bar, and you just want to make sure that everything is set and ready to go. So again, if you're doing this at this stage of the layout, you might be fighting a lot more wires than what I'm going to have to fight with to get these things mounted. Here's how the switch machines come. These are about $20 each. If you buy them singly, you can get them in 6 packs and 12 packs. Pretty simple. When you open them up, you have the switch machine itself, and then you have the instructions, and then you also have a tension bar, a screw, and then a small piece of piano wire that we're actually going to use to throw the turnouts. On the instructions themselves, there's a couple of key pieces here. Number 1, it gives you a template for drilling out the pilot holes for where we're going to mount it, and then the hole for where we're going to put the piano wire through to actually work the switch machine. It also gives a diagram of all 8 connections. So there are eight connections off the Tortoise switch machine. 1 and 8 are the power supply to the motor, so that's what we're going to focus on first. And then there's 2 single pole throw switches in here, and we're going to use one side to power the frogs, and we're going to use the second side to wire up some LED indicators that will indicate this position of the turnout, whether it's closed or thrown. So when you get the switch machines, here are the electrical connection pads. You can solder wires directly to this. I'm a little bit I don't know, I guess averse to actually soldering wires directly to these. So if I ever had to unmount them and mount them on a different layout, the wires might not work the way you need them. So you can get these edge connectors, and then this actually just slides in and connects. And now I can, actually should have done it this way. So now I can actually screw wires in here, and it's connected to the Tortoise switch machine. So I'm going to use these edge connectors. They're about $5 a piece off of eBay. So, you know, it's your preference. You can certainly directly solder wires to this if you want to, or you can get some of these edge connectors, and I'll be using the edge connectors to get the turnouts mounted. So first thing I'm going to do is, since we've already gotten the holes drilled, and again I've already addressed that part of the layout, next thing we're going to do is I'm just going to take a pair of needle nose pliers and take and bend the piano wire to correspond with this on the diagram on the instructions. This is to scale, so the piano wire is this length, so we're gonna bend the wire exactly as it is on the scale. So I'm gonna go ahead and get started on that. Okay, sorry, this is gonna be just a little bit awkward trying to do this with the camera. So you need to be pretty precise. So the first thing I'm going to do, I'm trying to work off the paper here as a contrasting background. Take the flat part of your needle nose here and just make a bend at 90 degrees. So give it a push. So again, hopefully that shows up well on the camera. You can kind of see it's not quite a 90 degree. Give it a little bit more torque here. There we go. So now I'm going to set this on the instruction sheet here, and I'm going to give it a little bit of a bend right here in the middle. Give it a little bit more of a bend here. So we'll just sort of overlay this over the top, and we have the wire bent to the specifications given in the instructions. So now I'm going to go ahead and get the switch machine over here and show you how to get it set up before we mount it. So now we just take this tension bar, and this will adjust the tension in the piano wire, and we'll actually make these adjustments when we can throw the turnout. So I'm just going to give it towards the top here to start with. And then I'm also going to take this small Phillips head screw and gently, and I repeat gently, put that on. This is the part of the motor that moves, and it's going to move the wire, which is going to be attached to the throw bar, and it's going to actually move the turnout. So we have to be careful because this is fragile and it's connected directly to the motor, so you don't want to use a lot of force. Just gently. Shockingly, of all the Tortoises I've ever done, this one is actually probably about the easiest one I've ever screwed on, if you can believe that. So then we're just going to finish the prep by pushing. Well, actually, you know what? I'm going to show you a trick. Right now, I'm going to leave this as it is. We're going to connect the piano wire once I get this mounted to the layout. So let's go ahead and get the first one mounted. Okay, so this is the location where the first one is going to be mounted, and what we've pre-drilled the holes for is, I'm actually just going to use, I'm sorry, it's not in focus. These are just number 4 1/2-inch screws, and they'll fit perfectly. So I have a little bin of these screws, and basically there are these cutouts in the switch machines. So right here, so I'm going to put this up here. Again, you want to make sure that the torsion bar is up to where the hole where we drilled out for that'll go up to the actual turnout. So I'm just going to go ahead and I'm going to put 2 screws in to start with to get this held in place, and then we're going to run the piano wire and we're going to test it to make sure it works, and then we'll put the other screws in. Sometimes you have to adjust these just a little bit to make sure that everything works the way we need it to. So I'm only going to do 2 screws to start with, and then once we are assured that the position of the turnout is correct, we'll go ahead and finish it off. So as I stated before, I'm going to show you a little trick here on, because if we were mounting this, we would have to get this guide wire up through the layout and through the hole in the throw bar. So I'm going to show you a little trick that will reduce the amount of issues you're going to have getting this mounted. So this is the turnout right here that we're mounting the Tortoise to. So I'm just actually going to feed this down from the top. So that's the beauty part about working on a shelf layout like this. I can hold it from the top side. I'm going to mount that 90-degree bend goes where the screw is. So I'm just going to again gently tighten this screw, and it will hold that piano wire in place. And now we're ready to give it a test. I know it's real difficult to see with the lighting, but this piano wire, so this is 3/4 inch, this is a 3/4 inch base for my layout. I know a lot of guys will put a layer of foam down, and this piano wire wouldn't be long enough to get through any layer of foam. So you can actually purchase piano wire from Hobby Lobby. It's in about a 15 to 18 inch piece, and I've actually done that on my other layout. I needed a little bit thicker wire than what that comes with the Tortoise switch machines. So I have about 1/8 of an inch I'm gonna have to trim off here when this is all said and done. But right now, what we're looking for is like this springy tension. So I'm manually pushing this over, and you can see that it slams back to the closed position. So now what I'm going to do is, sorry, I'm moving the angle of this table a little bit here. So I'm manually with my hand pushing the switch machine to make sure that it goes to the thrown position, which it does. And we're going to check for that tension in there. So that's, at this point, that's the key that we're looking for. When you're doing this manually, moving the black bar, you want to do it very, very gently, because you don't want it to damage the motor. So this switch machine is in the position that I need it to, the wire is in the position I need it to, so I'm going to go ahead and finish securing that in place, and then we'll worry about getting it wired up, and then I'll adjust that tension bar once we get it wired up and start running it with the powered motor. So let's go ahead and get this final secure the last 2 screws in, and we'll be all done getting this one mounted. Okay, so I got this in place and mounted. Just for now, for the time being, so I don't misplace them, I'm gonna stick this edge connector on here, just so we know where it's at. And then real quick, just because that's going to be the biggest that's the biggest module I'm putting underneath the layout. Make sure that the bench latches or closes, and it does. So we're good to go from there. So now I'm going to go ahead and get these others mounted. And then what I'm going to do for these 2 that have these extra wires, I'm just going to cut a couple shims out of that balsa wood, and I'm going to put that in place to just shim it so it's not going to affect and be offset by those wires. So I'm going to go ahead and get the remaining 3 Tortoises mounted, and then we'll come back and we're going to start doing the wiring with some terminal strips, and we're going to get everything hooked up to the SE8C so we can test it out and make sure that the switch machines work. Okay, so you can see I got the 4 Tortoises mounted. I got the piano wire run up through the throw bar in each of the turnouts, made sure that it was secured in place. Next thing we're going to do is I'm going to attach, and I know it's sort of hard to see with the reflection, these terminal strips, and it's just going to allow me to get the wires I need run close to the turnouts, and then I'll connect it from the terminal strip up to the snap edge connector. So I'm just going to find a suitable location for all of these. I'm going to try to get them as consistent as possible on the left side of the turnout, or the switch machine rather, because I'm going to run all the wires from left to right. So these are really simple to mount. This is just a 3/4 inch number 4 screw, goes right through here. So I'm just going to go ahead and get these mounted real quick. I'm going to mount one approximately here, here. This one's going to have to be sideways because of my SE8C, and then over there. So I'm going to go ahead and get these mounted, and then we'll continue on. Okay, you can see that I got all of the terminal strips mounted. Next thing we're going to do is we're going to connect these green wires that are coming from the frogs to the terminal strips, and we have to put it so it corresponds to slot number 4, or electrical connection number 4 on the Tortoise. So let me get a close-up look here, and I'll show you which one's number 4. So I'm just going to pull one of these snap connectors off. So there's only opportunities for you to solder, there's only soldering pads on what I'm going to call the inside of the Tortoise, or the part where you connect the piano wire to the switch machine itself. So we're just going to go ahead and count 1, 2, 3, 4, 5, 6, 7, 8. You're going to read it left to right. So regardless of the orientation of the Tortoise, we're going to make sure that it's going to be in slot 4. So for me, I'm just going to go 1 through 4, reading it top to bottom as I'm looking at this. And then I'm just going to wire it to slot 4 of the terminal strip. So we're just going to get these cut into place here. Give myself a little bit of slack here. I got my wire cutters. Make sure this gets into slot 4. Perfect, got that one connected. So I'm going to go ahead and get the other 3 connected, and we'll go ahead, and once we get the frogs wired up here, or at least the wire from the frog to the Tortoise, we're going to get power applied to these so we can go ahead and check them out to make sure they work. So I'm going to go ahead and get going on that, and then next thing we'll do is we're going to start soldering onto the SE8C. Okay, so I got all the frog wires connected to the edge, or not the edge connectors, the terminal strips. So now the next thing we're going to do is we're going to wire up the power wires that are going to come off the SE8C. Now if you look at the instruction manual on this, this actually reads from right to left. So this is terminal 1, 2, 3, 4, and so on up the circuit board. Now if you look carefully, this is the block connector that comes with the SE8C, and if you look carefully, there's actually 2 strips coming off here, a top row and a bottom row. I already wired up the black and the red for the power connector, but now we need to wire up all of the wires that are going to power the Tortoise switch machines. Now if you look at the instructions, The top row, or I'm calling it the top row, it's going to be the row that is closest to me when we mount it to the SE8C, are numbered 1, 2, 3, 4, etc. And the bottom ones are A, B, C, D, E. So the power strips here are actually in slots 3 and C. Now this will control 8 slow motion switch machines, and they're going to be the alphabet portion, or the lower half. We're going to go DE is going to control 1, FG is going to control Tortoise 2, and so on and so forth. You can control up to 8. So I'm going to wire black and red alternating wires off these bottom ports, and we're going to run them to the Tortoise switch machine. So it's going to take some time to get these soldered up, but the nice thing is, if you can see them here, there's actually like a little needle eye in here. So I'm just, and you can see it with the power connector here. I just made a hook with the wire, latched it in there, hit it with a little bit of solder, and we're good to go. So I'm going to go ahead and get these soldered up, and we'll go ahead and get them connected to the terminal strips as well. So that's going to be the next step. Okay, you can see I got this wiring harness all set up here. Now I wired these all black. Here are the 2 power wires. But the rest of these are all black, and the reason why they're all black is when they hook them up to the Tortoise in position 1 or 8, it doesn't matter which one goes to which. There's no correct polarity on this. So because there is no correct polarity, and I found this in the past as well, if I alternated black and red, the wires that I run from the Tortoise down to here, and then from here to the actual turnout control, it's hard to know which one is correct to make the turnout in a thrown versus closed position in terms of what the DCC system is seeing. So by making these black, if I have to alternate the wires around to get it to the correct direction of the turnout, I can do so, and it's not going to look like I have a black hooked up to a red and vice versa. So these are all black. Second thing you'll notice, and I apologize, I did not video this. So if you remember back from part 2, I had 2 wires coming off here, off the bus line, and I told you these were going to be feeders for the turnout machines. So I went ahead and run these lines as well, soldered these up and run them. So I've got 4 sets total. This first set runs over here, is going to go to this switch machine. These go to the other 3 switch machines. What these do is these are going to provide the polarity for the actual frog itself. So the green wire is the frog, and to get it to match the correct polarity of whether you're in a thrown position or a closed position, you need to have basically the energy from either rail A or rail B going to the frog so it matches. There's an internal switch within this motor, so when it switches, it's going to switch the polarity. So when you go to throw or close the turnout, it's going to change the polarity. So these are going to go in positions 2 and 3. So if you remember, the frog went to 4, the green for the frog went to 4. 5, 6, and 7 I'm going to use for my LED control panel. So what I'm going to do right now is, before I hook this back up, I want to get these wires taken care of. So I'm going to go ahead and get these 4 sets of wires connected to inputs 2 and 3 on all of the terminal strips. So I'm going to go ahead and do that, and I'll be back, and we'll get the strip hooked back up to the SE8C. Okay, so you see I got the strip hooked back up to the SE8C. Now the key is going to be to make sure we get the correct wires to the correct turnouts. First 2 are going to go to turnout 1, second 2, number 2, next 2, number 3, and the last 2 are going to come down here to number 4. So what I need to do is, just like what we did with these feeder wires, I'm just going to start running them. Probably going to start with the top set first and just sort of work myself through here. So again, I'm going to, pretty simple, I'm just going to cut the wires to length and get them run into place, and then we'll have power running to the Tortoise switch machines, and we'll be very close to being able to test one out. So I'm going to go ahead and do that, and I'll be right back. Okay, so I got those wires hooked up here, and again, making sure that we got them run to the correct switch machine, so when we go to throw the turnout, we're good to go. So the last thing we need to do before we're able to actually test one of these out is I need to run wires from the terminal strip up to the edge connector for the Tortoise. And there are still 3 wires here that I'm not going to wire up until I test these out to make sure they'll work. But I am going to run all 8 wires from these snap connectors down here to the terminal strip. So again, knowing that this is top is position 1, 2, 3, 4, 5, 6, 7, 8. I'm going to run black wires position 1 and 8. I'm going to run black to 2, red to 3, green to 4, and then 5, 6, and 7 are going to be wires that are going to power some LEDs on the front fascia. So I'm actually going to do a yellow wire in, which is going to be position 5, and then white wires out 6 and 7. And I'll show you what I'm going to do with that later, because I still have to run the wires up to the input on the terminal strip. But since I'm going to go ahead and wire these up, I'm going to pre-wire those last 3 wires. So there's going to be 8 wires going into the Tortoise, even though we'll get to the other 3 here once I get these wired up. So I'm going to go ahead and get one of these edge connectors wired up, and I'll show you how that works. Okay, I know I showed you this just a little bit ago, but to absolutely confirm it, on these circuit boards there is a printed number 1, so you know you're in position 1, because it is crucial to get this correct. So that's how we know that you're in the correct spot for the Tortoise. And then on these edge connectors, which is kind of nice too, bring this in here, get it in focus. Kind of see in between the screws and the terminal connectors, these are numbered 1 through 8 as well. So when we go ahead and install these, we just match number 1 up with number 1, so that way I know when I'm wiring these, we're good to go. So you can see that I pre-measured some wires out here, and pretty simple. Just put these in, tighten them in place. And we'll go ahead and get the other 7 in place, and we're good to go. So we're going to go black, black, red, green, yellow, white, white, black. Okay, so here's what the finished wiring looks like. So let's go ahead and get this connected to the Tortoise, and then we'll get it wired up to the terminal strip. So again, I'm just going to make sure that position 1 and position 1 line up. And we'll just snap that on there. And now what I'm going to do is just run these down in place, and I am going to trim them, strip the edges off, and get them wired up. And then once I get done with that, we'll come back and test out this first one and make sure it works. Okay, so here's what it looks like finished wiring. So a couple things before we test this out. We're definitely ready to test this out. So what you want the turnout to be in a closed position, that's basically when the point rails are allowing the train to go straight forward. And then when the turnout is in a thrown position, that's when the point rails move, and then the train will go to the diverging route. So we want our DCC system to know the difference between thrown and closed. And what's going to happen is when I test this out, if it's opposite of what the DCC system says, I need to change basically the wires from positions 1 and 8. So I'm going to switch these 2 wires around if in fact it's opposite what the DCC system says. Now we also have power running to the frog, and again, as the turnout switches from a closed to a thrown position, there's an internal switch within the Tortoise that's going to alternate between the rail A and the rail B, which is connected to the frog. So if that is opposite of what it needs to be, then you're going to change the wires in positions 2 and 3. You just change those two around because it'll change the polarity. And I'll just say I've probably mounted 50 Tortoises in my life. You have no idea until you test it out whether or not you have it wired up properly. So easiest way to troubleshoot is just to know which wires you have to switch. So let's go ahead and get this thing fired up and see what we got going on. Okay, so we got the DCC system powered up here. So on this particular Zephyr Express, the DCS52, to enter the switch mode, which will control any of your auxiliary stationary decoders, we're going to hit this S button up top here. It's going to default to address 1, so I can use my soft keypad here to type in whatever number that I want. You can reprogram these to be 101, 102, 103, etc. I'm just going to keep them as 1, 2, 3, 4 for right now. So it defaults to number 1, and down here on these menu keys, this key A is thrown, key B is closed. You can see up here, I don't know how well you can read it because it's pretty pixelated out on the camera. So it says switch 1 right now is in a closed position, and we'll just test that out. Hit thrown. You can hear the Tortoise moving. Hit closed. Okay, I'm going to pan the camera out so you can see the command and the switch at the same time. So the beauty part here, switch 1 right here, which is in close proximity to my command station. So again, it's in a closed position, meaning the train is going to go on the straight route, not the diverging route. Let's hit the thrown key. You can see that the point rails move, and now the train will go the diverging route. Hit closed again. So the direction of the turnout matches the direction of the command station, so we don't have to change any of those wires. So the next thing we need to do real quick is to double check and make sure that the frog polarity is correct. And once we verify that, we will have successfully wired this thing up. Okay, so this really becomes the real test here. So I have my railroad amp meter. I don't want my channel to be a shameful plug for any product, but I highly, highly recommend this. This saves you so much time troubleshooting if things aren't going well. Because the cool thing is I can just drop these 2 leads on the rail and the frog, and you can see that I'm getting a 13.9 voltage, which was similar to, I'll just drop it on one of these other rails. It's the exact same. Now one thing to check to make sure the polarity is incorrect, I'm going to go ahead and do the diverging route, and you can see I don't have any voltage, because the reason why is the voltage of the frog is going to be to the opposite rail. So with this being a closed route, this is rail A, this is rail B, so the frog is now powered for rail B. We know that the diverging route, or the outside rail, this is also rail B. So these two are actually the same polarity right now. So let's go ahead and I'm going to throw the switch. So now the train would go to the diverging route, and you can tell I didn't do anything different. Didn't pause the camera or anything. And now I wasn't getting a reading before the switch was thrown. Now the switch is thrown, I'm getting a voltage of 13.9. Go back and try to do it on the closed route, and I don't have a voltage. So this never happens. You're witness to history right here. This is probably the first time ever that I've wired up Tortoise that the direction of the point rails was correct and the polarity of the frog was correct. So this frog, or I'm sorry, this turnout is wired. We have a powered frog. I can control it with my DCC system, and soon to be, I'll be able to control it with JMRI as well. So I'm going to go ahead and get the remaining 3 turnouts wired up here, and I'll come back and we'll do a little show off here before we wrap up and start wiring on the control panel. So just real quick before I close this up or move on to the wiring up the remaining 3, I know there was some concern that I didn't have enough space in the box for the Tortoises. So you can see all the wires right here, and I know I'm not going to be able to get it on the camera real well, but I'm able to watch it as the lid closes, and I have plenty of space in there with those wired up. Wires won't catch on anything, so I can freely open and close this and not have any issues. So let's go ahead and get these last 3 wired up, and I'll come back and we'll work on testing out the remaining 3 turnouts, make sure they work, and we'll move on to wiring up the fascia with the LEDs. So we got the remaining 3 turnouts wired up, and everything works just great. All of the frogs, the polarity was correct on the first attempt. Only one of the turnouts I had to cross the 2 black wires to get it to line up with what the switch machine or the DCC station was. I'll flip this up here so you can take a look. So here's what it looks like on the inside. So if you are able to get your layout to this point, you have a fully functioning operating layout. I'm not going to run trains just yet, and I know that that's everybody's got a different preference. I'm confident. I know for a fact the trains are going to work on it, even though I don't have one out here in the garage to test out right yet. The turnouts work. I've been doing all the checking with my amp meter, so I know everything works. I might have to clean the rails here a little bit, but otherwise I'm very confident that this is going to work. So if you can get it to this point, you really technically can stop. You have a fully functioning train, turnouts that are controlled by your DCC system, powered frogs. We have everything set up for you to do a programming track, plug in JMRI, you can use your Y throttle. I don't have the proto throttle set yet, but that is a pretty easy setup. But I'm going to take this a little bit further. We haven't completely checked our BXP88 yet for the detection and the transponding features. That's going to be part of the wiring of the front fascia with the LEDs, and we're also going to set the direction of the turnouts by some color-coded LEDs on the front fascia. So take a deep breath. You've got a great layout going so far, and now we're just going to continue to develop it and refine it. Okay, so we're ready to start wiring up the front fascia with the LEDs. And before we get too far along in the process, first thing I need to do is figure out how many wires are going to run to the LEDs on the front panel. So off of my BXP88, I have actually 2 sets of 10 prongs, and I'm going to use the wires that come with the signal cable. It's a 10 wire harness, and there's a special design port or pin set that will fit in with there, and I can splice those off, and there's already resistors built into the BXP88. So this is just going to be a matter of running 2 sets of 10 wires down, and we're going to wire them up to the LEDs on the control panel. So I know I'm going to need 20 terminal strip ports for the BXP88. For each turnout, I need 3 wires. The 2 positive anode wires that are going to come off of the Tortoise, and then there's going to be the ground or the negative wire that's going to come off of my bus bar for my 12-volt power supply. So 4 turnouts, 3 wires per turnout. I'm going to need a total of 12 ports for that, 20 ports for the BXP88. So I'm going to need a total of 32. These come in 12 port strips, so I got 36 out of these 3 terminal strips. I'm gonna just use my shop knife and cut 4 of these off, and then what we're gonna do is we're gonna go ahead and mount them down here on the base of the layout. Reason why I do this and why I'm going to do this is simply because LEDs burn out, and having the LEDs connected to these terminal strips if I ever have to change one out, it's just going to be a matter of getting a new LED, soldering a couple feeds off of it, and then hooking it up to the terminal strip. I don't have to rerun wires all the way up to the switch machine. So I'm going to go ahead and get these things mounted here. So I haven't mounted these just yet, but there's before we do mount these, which is pretty simple, I'm just going to drop some number 4 3/4 inch number 4 screws through some of those holes. We have to take into account we have these switch machines that are hanging down, so before I permanently mount these, I'm just going to double check and verify that they're not going to interfere with the placement of my Tortoise. And good news, right where they're at will be a perfect location. It's going to give me access from either side to be able to have enough room to hook up some wires. So I'm going to go ahead and get some screws and get these mounted, and then we'll go ahead and start running some wires to the switch machines. So I'm just going to talk here for a minute while I'm getting some of these screws in. So this is, using terminal strips is not necessary at all, but you know, I've had enough experience with wiring that, you know, the more terminal strips you can add, it just, number one, it helps troubleshoot, it helps keep your wires neat and tidy, especially if you do have to troubleshoot. So I just find it's a good practice for keeping things nice and neat and organized. If you notice, what I'm going to do is I'm separating these out to where I'm going to have just a little bit of a gap in between the terminal strips that are going to connect the BXP88 for the detection LED wires, and then the terminal strip for the Tortoise switch machine wires. So again, we'll go ahead and get these finished up here. Don't have to put a ton of screws in, just enough to hold them in place. So I'm going to go ahead and get these finished up, and we're going to go ahead and start running some wires. Okay, so here's how this is going to shake out. So here we have our 12-volt power supply, and I have two bus strips here. So basically there's two ports that come off of the power supply. There's a positive and a ground. So I'm going to run the positive to the back bar and the ground to this bar. The positive is actually going to go up and run to the Tortoise switch machines, and I'm going to use a yellow wire as opposed to my usual red or black, so I know that it's the power supply for the LEDs. And then the return wires, I'm going to run two white wires back from the Tortoise down to these terminal strips, and that's going to be the wires that I'm going to use for the LEDs. Now, I don't have let me just rephrase it. I've been doing a little bit of playing around. These are the LEDs that I'm going to use. These are bicolor, red and green. It has a common cathode, so I'm going to wire the negative or the ground up to the common cathode, and then the anode. That's why I need two white wires coming off the Tortoise. So as the switch machine turns, it's going to change where the positive value is coming from. So if it's on the right side, this will be a red LED, and if it's coming from the left side, it's going to be a green LED. So I'm going to run yellow up to the Tortoise, two return white wires back, and I'm going to run the ground from here down to the terminal strip. So, and then the last thing I'm going to do is I'll actually run the wires from the power supply to the bus bar. So I'm going to keep the first two slots open to get those wired up, and then I'm going to get the Tortoises wired before I actually supply power to the bus bar. Just not that I would hurt myself, but it's just doing a lot of wiring like this. Just want to make sure that there's no chance you get hurt. Even though this is currently not plugged in, we're just not going to take any chances. So I'm going to go ahead and start running some wires, and once I get one set run, I'll show you what it looks like. Okay, we're ready to go ahead and wire up the ground, or the negative terminal, from my power strip down to the terminal strip for the cathode for the LEDs. Now, we actually are going to wire in a 470 ohm resistor into the cathode wire. So I've got 4 of these wires set up. I'm going to run them from the bus to my terminal strip, which will hook up to the cathode of the LED. So I'm going to go ahead and get that done, and I'll show you the progress once I get all 4 of these wired up. Okay, so you can see I got all 4 of the ground wires hooked up to the cathodes, common cathode for the bicolor LEDs. And this is what it looks like here. The resistors, I put some heat shrink on the wires to make sure that the resistors are protected and the joints are protected. So that's what we need to do for the cathode. Okay, you can see here I got all the wires hooked up. So the yellow is the positive feed into the Tortoise, and then the white wires are connected to the different poles of the internal switch within the Tortoise. And then the white wires run back down here to the terminal strip, and I'm going to be able to wire up an alternating red-green LED to know the location of the turnout. So you can also see that I ran the ground or the negative off the bus bar down to the power to the terminal strip. So now once I get the LEDs ready to go, all I have to do is just wire them into the terminal strip. I still have to get the power supply from the 12-volt power supply unit to the power bar. So even though all the wires are hooked up, they're still not quite ready yet. Before I do that, I want to get the last set of wires run down to the terminal strip, and that will conclude all of the wires that I need to run and ensure that they bend so the lid and everything closes. So I'm going to use Digitrack's pre-installed or pre-made cable, and I'll show you how to make the wires that come off of the 10-pin units that are on the BXP88 for the location detection. So here's just a close-up of the BXP88, and you can see that there's a set of 10 pins here and a set of 10 pins down there, and those are going to let us know exactly the location of any locomotive or resistor truck installed rolling stock, and we're going to wire that to the front LED panel of the layout. I'm going to use Circuitrack's or Digitrack's signal driver cable kit. This is originally designed for the signal mast, which we're going to use later, but it's also incorporates into the 10 pins on the BXP88. So I'm going to make 2 of these, one to plug into the top pin, one to plug in the second pin. I'm going to run them down to the terminal strip. Okay, here's a close-up schematic of what these pins are. So the first set of rows is zone power, then you have the wires for either 1, 2, 3, 4, 5, 6, 7, or 8, depending upon which set of pins we're working off of. Now it's really crucial. This shows here that pin 1, here's the edge of your circuit board. So pin 1 is the one that is, as I have the BXP88 oriented, it's in the bottom row in the back. Now the other thing, when you're taking a look at, and when we make the signal drivers here, and I'm going to try to see if I can get this to focus. Probably can't get this to focus. On the signal driver cable connector, there's a little arrow which is going to indicate pin 1. So we want to make sure when we're making the cable that we orient it to where we're making the cable where pin 1 is going to orient to pin 1 on our BXP88. So I kind of got the wires pre-run up here before I actually make the cable. Now again, you want to make sure that your brown wire is going to be pin position 1, which on my BXP88 is going to be up here, and these top row, it's going to be zones 1 through 4. So this is going to be the first 4 zones of my detection system. So to make these cables, it's pretty simple. I'm going to give myself just a teeny tiny little bit of slack here. I'm going to put the bottom clip here, and we're going to go ahead and push down, and again ensuring that the arrow on the clip is right where the brown wire is on the cable. So I'm going to go ahead and get this installed real quick, and then we'll plug it into the BXP88. Okay, so I'm going to put this up from the top. Again, my brown wire is down, and I know you can't see it on the video, but the arrow is right here, and it's for pin 1. So the key is to push this down, ensuring that the there's little blades within this connector, and you just want to make sure that they penetrate through and you get this to latch. Okay, perfect. So my wrists weren't strong enough to get these to latch, but you can see we have a good connection here. What I ended up doing was making just a mini kind of vise with 2 pieces of blocks of wood and pushing it down that way, and that's what the instructions recommend, to make sure that there's latches on here to make sure that they clipped tight, and that the little connectors within this port actually penetrated through the insulation of the wire, and we're going to get a good electrical connection with this cable. So now all I have to do is just plug this in, and again making sure that pin 1, where the arrow was, is towards the back and the lower left, or the lower right I should say, and there we go. So now I'm just going to trim the other end of this cable, and then we're going to connect it to the first 10 terminals on my terminal strip, and just remember that these are wires 1 through 4. So I'm going to go ahead and get working on that. Okay, I got those wires run from the BXP88. You can see them coming off right there. So I'm happy to say, and I'm glad to say, after about 2 months worth of work, I have all of the wires that are going to go from the bottom case up across the hinge to the top of the layout. So all of the wires are officially ran. I do need to still wire up the LEDs on the front fascia here, and I still need to wire up the signals, but the good news about signals is we're going to start them here with the SE8C. They're all going to be along the top main line there. So I'm going to use that exact same 10 wire ribbon Digitrax product for the signal head. So happy to get to this point, and I'm probably even more ecstatic that everything works. I'm able to close it. The wires don't bind up. So this is the first time I've done a layout like this where the top is on a hinge and moves, and everything worked out. Until you actually try it, you don't really know. So everything worked exactly how I wanted it to. Here's just a little bit of a closer up view of all the terminal strips that we installed, which are going to be used as a quick connect for the LEDs for the front fascia here. Next thing I'm going to do, I still have to get wire or power from the 12-volt power supply to the bus line, and that's going to be a pretty easy task. It's 2 wires. However, one of the things I am going to do for coming off the power supply is I'm actually going to install a potentiometer. And if you're not familiar with what a potentiometer is, really what it is, it's basically you'll find it in musical instruments, notably electric guitars. It's a volume switch. It's used commonly as a volume switch. Pulling it out of the package here for you. So what we do, you can see there's 3 prongs coming off here. The middle one is what we're going to wire the 12-volt, the positive wire coming out of the power supply unit. And then I'm going to wire a second wire off of the 3rd prong, and then I'm going to run that back to the bus line. So the reason why I'm going to add this potentiometer is because this is a variable resistor, and I have experience working with these LEDs prior to this layout, and these LEDs with a 12-volt power supply are very bright. And that's a twofold issue. Number one, it shortens the life of the LED, and number two, even though I don't plan on staring at the LEDs, if you have small kids or if there's people who are staring at the LEDs, it actually can cause you to get some flashes or some bright spots in your eyes because they are that bright. So this potentiometer is a variable resistor. So what I'm going to do right now is I'm going to solder feeder wire off here, which is going to come off the 12-volt power supply. I'm going to wire a second wire off of the third port here, and I'm also going to wire a resistor off of here. So I'm going to show you this. So I'm going to wire this resistor off here. It's just a 470 ohm resistor, quarter watt resistor. Here's the reason why. This is a 1000K resistor, and again, it's variable. So as you crank the resistance up, you're going to dim the LEDs, and as you turn the resistance down, you're going to brighten the LEDs. So what wiring this resistor into the circuit after the potentiometer limits the risk of me turning the resistance all the way down on this and having the lights actually be not resisted at all, and having the full current, which is really going to shorten the life of those bulbs. So it's just a fail-safe mechanism. It's really it will just magnify the resistance coming off the potentiometer, and it'll serve the purpose of dimming the lights. So I want to talk just real briefly about the reason why I'm doing a resistor coming off the potentiometer. And ordinarily, if you were going to use either of these power supplies for anything other than LEDs, you don't want to have any resistance. You want the full 12 volts. So basically, resisting the current coming directly from the power supply, it is going to be less than 12 volts running through that bus bar. Because I am only using this for LEDs, I can get away with a single resistor coming straight off the main power supply. If I were going to use this for some other auxiliary function, what I would end up doing is on each one of these wires here, of the white wires, I would have soldered a resistor in there before it actually gets to the bulb. So number one, this is going to save me a ton of time, and number two, it's just going to be a single resistor, and it's going to serve the purpose of what I need it for. Now the other thing is, I know I'm never going to use anything else with this particular layout, but the nice thing with this power supply unit, it actually has 2 positive X ports and 2 ground X ports. So if I wanted to, without having to rewire all this and add resistors to those wires, I could just run a second wire off of each of these, get a separate bus bar, and everything would be fine. So there are some options with this particular model of power supply, but in the case of this particular application, I'm going to go ahead and get this soldered up and do the resistor straight off the potentiometer. So I'm going to go ahead and get soldering. Again, you've seen me solder before. I'll show you all my circuit here before I get it set up and wired up on the power supply, and then we're going to test out some LEDs. So here's what the potentiometer looks like after it's all soldered up here. So here's my input wire, here's the output wire that's going to run to the bus bar. Here you can see I got a resistor in here, heat shrinked all of the ends up to it. I also, for testing purposes, here is a 3-way, or well, it's got 3 wires on it, but this is the red-green LED. And common cathode on this, so that's going to be the blue, and then the 2 power wires, and that mimics what's in my terminal strips. So let's go ahead and get the potentiometer and the ground hooked up to the power supply, and then we're going to be ready to test this thing out and make sure it works. So I'm just going to snake a wire through here, and going to go on the back side of it. I pre-measured this out, so we're good to go. But get this hooked up. I want this to be on the bottom, or let me rephrase that. I want this to be underneath the wire for the potentiometer. So we'll run that back around here, drop this into the ground slot. I purposely made the wires on the potentiometer a little bit longer than what I think I need, because I just want to make sure that it's going to fit where I want it to. So the ultimate goal of this is I want the potentiometer to sit about right here. So the input wire, gently, just going to kind of bend that back, make a couple 90-degree bends with it. The other one I'm going to run behind the heat shrink to make sure that that's going to be good to go. So I'm going to mount this about right here. So I'm going to go ahead and just mark, and I'm going to clip this off and get these wires trimmed up, and I'll show you how I install it. Okay, got these measured up where I want them to. So I'm going to go ahead, again, just snake this underneath here. There we go. So I'll get it hooked onto the bus bar first. Okay. Got the potentiometer wired up here. What I'm going to do is I'm just going to get like a 3M command strip with the double-sided adhesive and put it on here and get that secure down. But before I do that, I'm just going to test it to make sure it works good. So I'm going to take one of my LEDs here. I'm just going to wire it up to import number 1. So I'm going to put the common in first. So this is wired up to turnout number 1, or switch machine number 1, or address number 1. Get that taken care of. So once I get this wired up, I'm going to power it on and see what we got going on here. Okay, got everything squared away and wired up here. I purposely set the potentiometer right at about 50% resistance. So here's the LED right here. So I'm going to go ahead and plug in the power supply for the 12 volt. You can see immediately the LED, and I don't know how well this shows up on the camera, shows up green. So here's my potentiometer. So I'm just going to give it a little turn and see it gets really bright. Turn it to the left, you can see it gets really dim. So potentiometer works. Cool, cool, cool. All right, now I'm gonna move the camera out just a little bit here so you can see. And again, I apologize for the lighting on all of this. So this is wired up to switch machine number 1. So I'm going to go ahead and hit S on the keypad. So 1 is already entered. You can see I know it's in a closed position right now, so I'm going to go ahead and throw it. So watch the LED up here. Whoops, need track power on. Switch 1, thrown, turns to red, closed, turns to green, thrown, turns to red. So we successfully wired up all of this. So now the switch machine controls the LED. Again, one of the things, I don't know how well the camera actually shows it. If you go back here, I'm gonna close it. The green LED is just marginally brighter than the red LED, and that's just a quirk of this particular brand of LEDs that I'm using. The green has a little bit higher voltage than does the red, therefore it's just going to show up a little bit brighter. So there's going to be a little bit of difference between the greens and the reds, but otherwise we did this successfully. There's a nice little cap that's going to sit on our potentiometer, and like I said, I'm going to go ahead and get a piece of 2-sided tape, get that glued down or secured in place, and then I'm going to check the remaining 3 turnouts to make sure they work. And then the next step is we're going to start drilling some holes and mounting LEDs. Okay, so I tested and verified that everything works with my terminal strips. I want to talk real briefly about what I did with the LEDs. You can order these off of Amazon. I got all these off Amazon. You can get about 100 of them for literally pennies on the dollars, $4 or $5 per 100. So this one here, I'm using 2 different LEDs. This is a red-green bicolor LED. This is a soft white monocolor LED. So you can see the bicolor LED has 3 connections, whereas the single color LED only has 2. You need to identify which is the anode and which is the cathode. The anode carries the positive charge, the cathode is wired to the ground. On the single or monocolor LED, the cathode, again, look at your manufacturer, but the cathode is usually the shorter of the 2 leads. But the other surefire way to tell, and I know there's no way this is going to show up on the video because it's hard to see to the naked eye, where the lead connects to the actual bulb, there's a flat surface, and that's how you know that that's the cathode. So regardless of the length of your leads, look for the flat edge, and that's universally the cathode. On the bicolor LEDs, there is a common cathode, so both colors, the red and green, share the common cathode, so that's why we wired it up the way we did. We ran the anode up to the Tortoise, ran 2 white wires back, so then it alternates when the Tortoise switches. It's going to alternate the electricity between either of those anodes, and it's going to make the LED shine red or green. When we go to hook these up here in just a minute, these are 5mm LEDs. Again, you get these off eBay. These are LED holders, so the LED will fit from the back side of the holder up through the socket, and it'll hold it into place. And here's just a test LED that I have put in place. So we push the LED, and you can tell it's stuck in here pretty good. These hold really nice. But you push the LED in from the underside, and then there's little clips on here, so then when we go ahead and mount these into the holes we drill, it holds everything nice in place. So I've already pre-wired my LEDs, and I did them all white and blue. So the white is going to be the anode, the blue is going to be the cathode. We have everything pre-wired and ready to go. I put heat shrink around the edges. I recommend either using heat shrink or electrical tape, because when we put these in the LED holders here that are going to go into the bench work, it's going to hold the wires tight, and you just don't want to get a short where the anode and the cathode touch. So either electrical tape or shrink wrap will do the trick for you. So let's go ahead and get the holes drilled that we need for the LED. So looking at my track map here, I'm going to drill a hole right where all 4 turnouts are at, and then there's 8 detection zones. Here's 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to drill 8 holes for the detection zones, and then right over here above my UP5 panel, I'm going to drill 2 holes, because the BXP88 has 2 zone power outputs for LEDs, and those are critical because how those flash will tell us if there's a short, if there's any kind of an issue within that detection zone. You have to pre-measure the size of hole to make sure that your LED holders fit. These particular ones are 3/8 inch bits, so I'm going to go ahead and grab my drill, get these drilled out, and I'll come back and we'll start assembling our LEDs. Okay, you can see I got my holes drilled out. So basically what I'm going to do is I'm going to take one of my bicolor LEDs here, get the cap on it, get that slid in there like that. This is going to be for turnout number 1, which is going to be right here. So we'll just go ahead and feed these wires through. That nice and snug in place. So you can see the LEDs right there. Now on the inside, it's just a matter of remembering this is turnout 1, 2, 3, 4. So I'm going to run this over to number 1. So I'm going to get those wires trimmed in place, get them wired up, and then I'll go ahead and turn this on and show you how it works. Okay, you can see I got the wires hooked up here to position 1. Here's my LED right on the front fascia, which corresponds to turnout number 1. So let's go ahead and get some power onto this here. So you can see when I apply power, we've got a green indicator from the LED. Let's go ahead and close the lid. I'm going to back it out here just a little bit. Sorry about the motion there, guys. So turnout number 1, I'm sure it's probably hard to see, is in a closed position. So let's go ahead and throw it. That should change to red. Close it. Should change back to green. So we have successfully wired up turnout number 1 to the Tortoise. So now I know, looking at the fascia, if I have a green signal, that means that it's going to go on the straight route. If I throw the turnout, the red is going to indicate it's going to go to the diverging route. So I'm going to go ahead and get the other 3 turnouts wired up, and then we'll go ahead and I'll talk you through how we're going to wire up the LEDs for the detection indicators. So I've gone ahead and wired up the LEDs for the detection zones, and this is broken up into 2 zones, and I kind of talked you through that when I connected the ribbon wire here. And you can see on the screen right now, I actually created a printable chart that shows which wire is the anode and which wire is the cathode for the LEDs coming off of the BXP88. So we have black and white and gray and purple and blue and green, yellow, orange, red, and brown. If you remember, pin 1 is the brown, and that's actually the cathode. I'm sorry, the anode, which is pin 1. And I got all the wires hooked up. The white is the anode, the blue is the cathode. So you can see I got all those hooked up. 2 detection zones, detection zone 1 and 2, and let me show you how we got these wired up. So on the front fascia of the layout, here are the turnout indicators. Right here are these 4 LEDs, which I put right in to where the turnout separates out to the diverging route. And then I broke, if you remember way back when we wired the layout, we just did it sequentially. This is zone 1, or I'm sorry, detection section 1, 2, 3, kind of reads like a book. Here's 4, 5, 6, 7, and 8 over here. These are the zone power buttons, or zone power LED indicators, to make sure that both detection zones are functioning properly. Both of those should be on. So when track power is on, I'll see the light on my UP5, and I'll see those 2 light up as well. So I'm going to go ahead and plug this in. We're going to test out our LEDs, make sure that the turnouts work okay, and then I'm going to grab a locomotive and we're going to test and make sure that the detection zone indicators are wired up properly and it's detecting the locomotive. Okay, so the first thing we're going to test out are the LED indicators. So again, here's turnout 1, 2, 3, and 4. So I'm just going to go ahead and start running through here. Start with switch 1, turnout 1. I'm going to close that. Changes to red. We're going to go ahead and change turnout 2. Three, and then finally 4. So all of those work quite nicely. I do have track power on right now, no locomotives on, but you can see that I've got a solid red LED indicator for both of my power zones for the BXP88. So that's telling me that the BXP88 is working properly. So I'm going to go ahead and get a locomotive, and we're going to test out to make sure that the detection zones work as they are intended. So I'm kind of doing a test here. I have a Athearn Genesis GP9 sound locomotive. Ironically, this is the very first sound locomotive I've ever purchased. It's about almost 8 years old now. And here's how I have the layout broken down in terms of detection zones. This is 1 and 2. There's a very small gap in the rail right there. 3, 4, 5, 6, 7, and 8. The turnouts are not included in the detection zones. You can certainly wire them in there. I did not, because I wanted to show a normal wiring of how you would wire a layout without detection zones or the BXP88. So the turnouts are not included. So what I'm going to do is I'm just going to run the locomotive across these two sections here, run it back, and then throw the turnout and check out the diverging route on this particular zone. So let's go ahead and fire this up and get her started. Hit track power. So you can see that the test worked, everything worked the way it's intended to. So we've successfully wired this for turnout indicators with our LEDs, and we also correctly wired our BXP88 for detection. Later on in another video part of this series, I'm going to take a piece of rolling stock and actually add a transponding decoder to it, because the BXP88 will actually transpond equipment or locomotives that are transponder equipped. This particular one is not transponder equipped. It'll send it via LocoNet. So look, just as a side note thing, this is one of the coolest things I've ever done with a model railroad, being able to do detecting like this. This is going to come in very important when we get into doing the signaling, because the detection of the layout or the ability to detect where the train is on the route will automatically change the signal. So I can't wait to show you that. But really right now, until we get to the signaling aspect of it, we are done with the wiring of this layout. Everything worked as it is intended. Last thing we're going to do to finish up this particular part of the video series, I'm going to end up doing just a little bit of finishing work. I'm going to put some rail ties in there where we had to cut for our track. Wanted to make sure that everything worked before doing that. And I'm going to hand paint the rails a lighter rust color to give it a little bit of a contrast between the dark brown mocha color of the ties. So let's go ahead and start with getting the ties in place, and we'll start with the track painting. So if you remember way back when we painted the track, I also painted some of these ties. These are wooden ties specific for model railroading, and you can get them again off any auction site, Amazon site. Basically, it's just a small pre-cut piece of wood. You do have to measure against the ties that you have. I did have to trim probably about 1/16 of an inch off of each of these to make sure that they were flush with the ties that are with the flex track. Basically, they're pretty simple. These have a lower profile, so they just slide right underneath where your rail joiners are at. Gives you a nice finished look for where you had to cut the ties for the turnouts and the ends of the flex track. And basically what I'm going to do is I'm just going to sight these and get a so these ties have a lower profile than the actual plastic ties, so they're designed with that lower profile to sit comfortably underneath the rail joiners, and it just finishes off the look of where we had to trim the joint or the ties off the end of the turnouts and the end of the flex track. So I'm just going to sort of pre-fit those in there, and what I'm going to do, real simple, is just take a couple dabs of white Elmer school glue, and we just glue these into place. So I'm going to go ahead and get my glue, get these glued into place, and then we'll commence with the track painting. So painting rails is a pretty time-consuming process, and basically what I have is Tester's flat rust paint. You can get this at any hobby store, and if you kind of take a look at the label here, you can see I got this at Hobby Lobby. It's $1.79, and I have a very, very fine tip brush. And number one, make sure your paint is mixed up nice and good. And what we're going to do is, again, we're just going to hand paint this part of the rail right here, and I'll get in a little bit closer, tighter shot once I get the paint opened up here and get it mixed up. But basically, we're just going to paint the rails like it'd be a rusty color. This is a hand process, and it's just one of those time-consuming, very time, patience, virtue type project. You want to make sure that you just take your time and do it well. Probably take me a couple hours to get all these rails painted, but I'm going to go ahead and give this a start. Okay, I apologize, the lighting in here isn't the greatest. I don't have, still out in my garage till I get the rails painted here, so I don't have the greatest lighting. But basically you just dab a little bit on your paintbrush, and I'm going to go in here and I'm just going to sort of paint the rails. So once I get all of this painted, I'm going to take my bright boy and I'm actually going to take the edge off the top part of the rail, which overhangs the main body of the rail, to give it that nice bright shiny look like you had trucks, railroad, trucks of locomotives and rolling stock going over and giving it that nice bright shine to it. So go ahead and paint on this for a while, and I'll get the layout down in some good lighting, and you'll really be able to appreciate what the hand painting of the rails is going to look like for your layout. Okay, so I spent about the last 4.5 hours total to get all the track painted up, and you can see how everything kind of came together here. You can see that I've got basically the body of the rail and the top part of the I-beam. I took my bright boy and got the paint off the rails to give it sort of that shiny appearance. I did leave a little bit of paint on the rail on the backside here, so I'll just show you how I clean that off. But this is what weathering the rails looks like. Again, it's a time-consuming process, but the results really, I think, give you a real level of realistic look to your layout and your rails, and it gives a little bit of a contrast between the rails and then the mocha brown color that we painted the ties. So let's go ahead and clean off the rails that I left to get cleaned off, and then we'll be done with the track painting. Okay, I know it's really difficult to see, and I've got some lighting in here. I'm trying to really project this so you can see kind of right in through here. When I painted the rails, I used a really fine brush, but obviously some paint got up on the I-beam part of the rail. So I'm just going to take my Bright Boy, and I know I got it zoomed in here pretty good, and I'm just going to go ahead and burnish that off there and get the paint off the I-beam. So you can kind of see that right there where we got it cleaned off. And again, time-consuming process. It took me probably an hour and a half, 2 hours to burnish that off. But again, gives it a nice realistic look to the rail. So I'm going to go ahead and get this finished off, and then we'll go ahead and do the last little bit of cosmetic stuff to the layout here, and we'll conclude part 4 of the video. Okay, now that I got the track all cleaned off here, what I'm going to do is I have enough, I think, barely enough space. I've got a holder for my proto throttle. I'm going to set that in there. And so here's my proto throttle, and I just want to make sure I'm able to get this in here. I want to be able to have my proto throttle stored in here, so when I'm taking this from place to place, it's nice and secure. So just to make sure we got good clearance in there. I'm able to slide it out without interfering with any of the electrical components. So that should be set. This proto throttle holder, it's just a piece of plastic, and there's 3 holes in there. So I'm just going to use some number 4 wood screws. I'm going to screw that down and get that into place. And then what I'm going to do is I have some 3M straps, sort of those adhesive things where I'll be able to run a strap across there to keep the proto throttle nice and secure while it's in transportation. So I'm going to go ahead and get this screwed down. Okay, so I got the proto throttle holder in place. Here's the safety strap that I was telling you about. So this will just release, be able to slide this right on out of here, and I just have a nice secure place to hold my throttle when I'm transporting the portable layout. So pretty slick little gadget, and like I said, it'll keep the proto throttle safe and secure, and don't have to worry about dropping or anything when we're in transportation. So now I have one more proto throttle holder, and this is for the to hold it while it's in operation. This is a pretty slick little gadget. There's a back face plate here, which I have to install after I get it mounted to the bench work. So that just sits on there, and then the proto throttle just sort of cradles it. So you can sit it, it's at a nice little angle here, and you can either operate it in the cradle, or you can, since it's wireless, you can walk around and use it that way as well. So this is pretty simple. I'm just gonna get it seated here, pull this faceplate back off. Again, just 4 holes here. I'm gonna use some number 4 wood screws and just get that nice and mounted with those 4 screws and get it set in place. So another thing I'm going to do is I'm going to mount my railroad amp meter right here. It's got these holes pre-drilled in the circuit board, so I'm just going to, because there's a transistor in the back, I'm going to use inch-long screws and only drive them in about 1/4 of an inch or so, just enough. This thing is light, but that way, again, this will travel with the layout, so I can show it off to whoever want to see the track power in action. So I'm going to go ahead and get these 2 screws mounted and mount the amp meter. Okay, so I got that mounted. So again, just 2 screws, pull it right off through the circuit board. That'll keep it nice and secure in there. Obviously you have to be real careful, making sure to try to keep the layout fairly level, which that's what the intention is. You don't ever want to try to flip this thing up when you're transporting it, to just keep everything nice and safe. So there's one last thing I want to do, and I'm going to flip the top down here to show you what I'm going to do. And basically what I'm going to do is, the biggest risk with this layout right now is running locomotive or rolling stock off the back of the track, since there's no bumpers or anything. If I install track bumpers, it will take up too much of my operating space. So what I'm going to do is I'm just going to drill down into the layout, and I've just got 1/8 inch wood dowel that I'm going to cut off, probably about 1/4 inch, 1/2 inch high, and it'll just prevent the rolling stock or locomotives from going off the rails. So here's how this is going to work. Here's my dowel. Here's what it looks like. Sorry, it's not in focus. Take a drill bit and just put a piece of masking tape on it for how far you want to drive the drill or the hole. So you just are going to stop drilling once you get the masking tape to the... And there we go. And then this dowel fits right in there. And I'm going to put 2, I'm going to evenly space them out. That way the coupler won't actually hit the dowel. The coupler should go between the 2 dowels. So I'm going to get these holes drilled out and get all these dowels cut and put into place. They have a nice snug fit, so I think I'm probably not going to glue them in, just because they are a nice snug fit. And I'm going to paint them a different color, probably yellow, something that contrasts the end of the rail. So I'm going to go ahead and get these all drilled out and get them placed. Okay, so I got all the holes drilled and I got my wooden dowels installed. Again, these are just, they're not secured in there, so the holes are just drilled out to the depth that I want them. They'll hold nice and secure in place. Here's what I like about these. Again, track bumpers would take probably an inch and a half away from my overall running length, and here's what they're designed to do. So as the rolling stock closes in on the end of the track here, you can see that I know it's hard to see in the camera, but the coupler clears and the wood dowel actually will catch on the truck. So these little guys will just help make sure that if you're not paying attention, you don't have rolling stock or locomotives run off the rail. So handy little design, and it doesn't detract too much from the overall appearance of the layout. So that is how those are designed to work. Last thing, I had a couple pieces to glue on here to get this installed. So my proto throttle holder is installed and in place. So I got that taken care of, and the one on the inside for transporting the proto throttle when this is in transit. So that concludes part 4 of my video series, and this layout is absolutely fully operational at this point. Everything is installed and in place. The wiring is complete with the exception of the signals. I got my command station, everything set up and ready to go. Flip the top open here. So again, we have all of the electrical components installed and in place. So at this point, if you want to call it good and run your layout without signaling, that is absolutely fine. I still have a couple things that I'm going to finish up in part 5 of the video series, where we're going to hook the computer up, get JMRI running. I still need to program the receiver for the proto throttle and get that up and running, but otherwise we'll get the signals installed, get those last couple components taken care of, and we're good to go. So thank you for watching part 4 of my video series. I appreciate it. If you have any questions, be sure to leave a comment. Thank you so much.